Hi everyone. In this video, I will demonstrate how to sketch a sinusoidal graph by applying transformations to the cosine function. The approach is similar to the one that I used in another video based on the sine function, but I've introduced a couple of differences in this example. So the function we want to graph is y equals 4 cos 3x plus 90 degrees plus 2. And I notice right away that this equation is actually not in the correct form for a proper interpretation of the horizontal phase shift. So I will first have to factor out the 3 from the cosine argument to get y is equal to 4 cos 3 times x plus 30 degrees plus 2. And just be sure to do this yourselves before you get too far into the graphing. So now that we've got that done, we'll start with one cycle of the cosine function, and I've labeled the key points, namely the two x-intercepts, the two maximum points, and the single minimum point. I will apply the transformations to these points in the proper order to find out where this cycle ends up. Okay, so the first thing we're going to do is notice that the amplitude is 4, or I should say the vertical stretch factor is 4. And so this indicates that we have to take each of these key points and vertically stretch them by a factor of 4. So we'll do that right now. And you can replay this part in the video if you want to confirm that all of the original y coordinates were multiplied by 4. I mean, just take a look here. We were at 1 here. The maximum was at 1 on the y-axis. Now it's at 4, right? 0 times 4 is still 0. Negative 1 times 4 is negative 4, etc. Next, we can apply the horizontal stretch factor, which is actually 1 over 3 because the b value is 3. Now remember that the b value tells you how many cycles you can actually fit on the interval between 0 and 360 degrees. So here's 0, here's 360 degrees. We've got one cycle, max to max, right? One cycle that fits between 0 and 360. But if the b value is 3, that means in our new graph we should be able to fit 3 of these on the interval between 0 and 360. So if that's the case, how many degrees then would you need for each cycle? See if you are correct as I apply the horizontal stretch. Okay, so if you predicted 120 degrees, you're right. 1/3 of 360 is 120, so the period of this graph is 120 degrees. Next up are the translations. The phase shift is 30 degrees to the left, according to our equation. So now we're shifting 30 degrees to the left. Now from here to here is 60 degrees, so halfway would be 30 degrees. Each point is shifted to the left by 30 degrees, and the displacement is 2 units up. Okay, so whereas before we were at 4, at least this x was at 4, now it's at 6. Right? We used to have an x down at negative 4 plus 2, it's now at negative 2. To sketch the rest of the graph, we can add additional points based on the pattern of the 5 key points to produce another cycle. Okay, so what I did here was, these are the 5 points of my first cycle, and so I want to repeat that over the next 120 degrees. So this point here shifts over 1, 2, 3, 4, 5, 6, 7, 8. This point shifts over 1, 2, 3, 4, 5, 6, 7, 8 grid squares. Okay, so these 2 points become these 2 points. This point here shifts over 8 to this point. This point over here shifts 8 over to the right over here, right? So we essentially will have another cycle graphed. But I'm just going to do this one more time so I can round out this interval from 0 to 360. So I'll apply some more points. Then simply join all of those points with a smooth curve to produce 3 complete cycles. Now what I can do is extend both sides to give us the final graph, which looks like this. So there's a way to apply transformations to a cosine function in order to produce the graph of a sinusoidal function.